Everybody. So this lesson is sort of part 2 of what we started yesterday. We started looking at right pyramids and cones. Yesterday we focused on the surface area. And one of the things that was important with the surface area is we had to use the slant height when we were trying to figure out the area of the triangle, okay? Because the slant height in a pyramid is the height of that triangle, the two-dimensional triangle, okay? Today we're going to shift our attention, we're still going to talk about those shapes, but we're going to shift our attention to the volume. And the volume is actually derived pretty easily from the volume of a prism and the volume of a cylinder with the same dimensions, okay? So we want to just develop that first together, and then we'll answer some questions together. So there is a relationship between the volume of a pyramid and the volume of a prism with the same dimensions. So when I say the same dimensions, we're talking about the same length, width, and height, okay? There exists a similar relationship to the volume of a cone and the volume of a cylinder with the same dimensions. To look at this visually, we'll watch a couple videos. Now, we're actually not going to watch the videos together here. Essentially, though, I want to just tell you what would have happened if we watched the videos together. Let's say I had a rectangular prism, okay? And let's say that that rectangular prism was 3 by 4 by 5, just to make things easy in our dimensions. Now, let's say I had a pyramid that was also 3 by 4 by 5, okay? And let's say both of, so this is a prism and a pyramid with the same dimensions, okay? Now, let's say both of these were hollow so I could fill them up, okay? And let's say this was empty and I filled this up right to the edge and dumped it in, filled it up, dumped it in, okay? What you would notice is I would be able to put exactly 3 of these, the volume of 3 of these, into one of these, okay? So think about that for a second. If the volume of your prism is base area times the height, then the volume of the pyramid becomes 1/3 base area times the height. Because if I could put 3 of these into one of these guys, then that means the volume of this guy has to be 1/3 the volume of this guy, okay? And then likewise, it's the exact same for a cylinder. If the volume of a cylinder was pi r squared height, then the volume of the cone ends up being 1/3 of that, okay, for the exact same reason. So that would be 1/3 pi r squared height, okay? So that's where those formulas come from. I don't want you to just look on a formula sheet and think that we just haphazardly made up those formulas, okay? They derive from other things we know. Everything in math derives from something else that we know in math. Okay, so the volume of the right pyramid is 1/3 base area times the height. Again, I just want to take a little moment to caution you. This big B here doesn't mean a base, it means a base area. So whatever shape creates the base, you need to find the area of that shape. That's not a one-dimensional item there, that's a two-dimensional item there, okay? And then the volume of the right cone, I just established with you as well, would be 1/3 pi r squared times the height. Okay, all right, so let's try a few things together. Calculate the volume of a right square pyramid that has a slant height of 7 and a base of 2. Round your answer to the nearest 10. So I need to start with the formula, fill in what I know, figure out what I don't know, all of that sort of stuff. The formula here is 1/3 base area times height. I don't know the height, but I do know the slant height. So actually what I have to do is I have to figure out the slant height. Remember I told you yesterday, we as math teachers love to do this. We love to give you the slant height when you actually need the height, and we love to give you the height when you actually need the slant height, okay? You need the slant height for surface area, and you need the height for volume, okay? And we love doing that because then you have to throw the Pythagorean theorem into the question as well, so we get to see how you're communicating all those thoughts and ideas to us, okay? So I'm working with the slant height. Slant height squared will equal the r squared plus h squared. I have R there somewhat arbitrarily. It's just I probably copied and pasted it from one where I used cone. The letters themselves don't really matter there. Um, so the R there meant radius, but it's not a circle here, so we wouldn't actually call it a radius. Okay, so I know that the base is 2, so that my R value there would be 1, right? Because if the height is going from the center to the edge, it would be half whatever that base is. So I have 1 for R and I have 7 for slant height. So now h squared is going to end up being 7 squared minus 1 squared when I do some algebra there. Okay, so that gives me 48, and so I'll call h the root of 48 right now. Okay, I don't need to simplify that because it's not a final answer, but I don't want to write it as a decimal either, because then I might run into a rounding error. Okay, so now I'm ready to go into the volume of the pyramid, which would be base 1/3 base area times height. Okay, I know my base area will be 2 by 2, and my height will be the root 48. So I go 1/3 times 2 times 2 times root 48. You can look at that 1/3 as a fraction, or you could look at it as division of 3 if that is easier to type in your calculator. You can go 2 times root 48 divided by 3. Just make sure that your root 48, you are outside of the root before you divide by 3. You don't want the division of 3 to be underneath the root. Depending on your model of calculator, that might be that you have to right click out of the root, or it might be that you have to close a bracket. Okay, so just depending on who you are. And that's not a TI Casio thing, that's more older model versus newer model thing. Okay, so just depending on the model of your calculator, make sure you're out of that square root before you divide by 3. You should get an answer of 9.2 feet cubed when rounded properly to the nearest tenth. Okay. All right, calculate the volume of the following square pyramid to the nearest cubic inch. This time, again, I gave you the slant height and I gave you the base. So actually a very similar question to what we just did. I have to figure out the height first. So I'm gonna go 6 squared equals 2 squared. Okay, remember the R there would be from the center to the edge to make this triangle, if you can see that. Okay, so that piece there would have to be 2. So I'm going to go 6 squared equals 2 squared plus h squared. I'll go 6 squared minus 2 squared. So that's going to give me 32, and then I'll call h the root of 32. So now the volume will be 1/3 base area times the height. The base area is 4 by 4 because I'm looking at a square. So I have 4 by 4 by root 32. Plug all that into my calculator. You should get 30 inches cubed when rounded properly. Okay, again, watch your rounding and watch that you have the right units and the right exponent with your units. If you're talking a linear item, there's no exponent there. If you're talking an area item, that's a square. And if you're talking a volume item, that would be cubic. Okay. All right, a pylon is in the shape of a right cone. If the cone has a height of 30 centimeters and a volume of 3,100 centimeters cubed, determine the radius of the base of the cone to the nearest centimeter. So, like every question we've dealt with together, start with a formula, fill in what you know, figure out what you don't know, okay? So we're talking about the volume of a cone. So I have 1/3 pi r squared height. In this instance, I know what the volume is, so I'm going to replace my v with 3,100. I know the height, so I'm going to replace my h with 30, and I'm asked to determine the radius, so there's no Pythagorean theorem going on here. I just have to work this particular formula and figure out what the radius is. So I plug in the things that I know, okay? Now, you might want to take these two numbers together, 1/3 times 30, that would be 10. So we're looking at 10 pi r squared, and then you could divide both sides by 10 pi. Alternatively, you could look at this and multiply both sides by 3 to get rid of the division of 3, and then divide both sides by 30 pi. It's the same answer, it just depends on what you see first, okay? So I happen to do that multiplication first. I took 1/3 and multiplied it by 30. That's where I get the 10 pi. Okay, 1/3 times 30 is 10. Now I want to divide both sides by 10 pi. A reminder that when you go to divide by 10 pi, if you are a TI kid, make sure that your 10 pi is in brackets. What I did here is I just reduced it. So I knew that 3,100 divided by 10 would just give me 310. And so that's why there's no 10 on the bottom here. See how I dropped a 0 up top here? I actually did the division of those numbers. Okay, so that's why I've got r squared equals 310 over pi right now. Now I'll just take the square root of that and round my answer properly. So it was asked to the nearest centimeter, so I'd have 10 centimeters as a radius. Okay, 10 centimeters as the radius. All right, so that's it for this one. This was kind of a short one. Questions for you to take a look at, and make sure you're being neat, make sure you're showing me all the steps. The process is always more important than the answer, okay? And connect with me if you have any questions, okay? All right, guys, take care.